Welcome back, ladies and gentlemen. We are continuing our discussion on perpendicular lines in this video. Remember, the goal as a whole for this unit was to understand that we are going to find the distance from a point to a line in a coordinate plane, which we did in our previous video. We are going to use certain theorems regarding perpendicular lines to prove some mathematical statements and draw conclusions. And that is where we stand in this video. We are going to be identifying an extremely important theorem known as the linear pair perpendicular theorem. And in this video, we're going to identify it and utilize it to conclude a scenario about a diagram. So let's take a look here first and foremost. Now, I'm not going to actually physically prove each one of these theorems. A couple of them in future videos I will, but I'm going to try to do my best to do kind of a very informal, just kind of auditory proof of it. So let's dive in. Linear pair perpendicular theorem. What does it say? Well, it tells us that if in fact that G intersects H in such a way that the linear pair angles 1 and 2, they become congruent, then the lines must be perpendicular. How does that work? Well, very informal. Let's think about this. A linear pair, what is it? Remember, a linear pair is two adjacent angles that form a straight line. Well, a straight line adds up to 180 degrees. So what we're saying here is that the only way that two angles can add up to 180 degrees and both be congruent to each other is if what happens? Well, they both have to be 90. Just for example purposes, if two angles, both the same value, add up to 180, the only way this works is if both those angles equal 90 degrees. Okay, so very informal kind of proof of just of where it comes from. Let's utilize it in some context here. So it says, is n perpendicular to S? Is n perpendicular to S? Explain why or why not. Well, n already is perpendicular to T, so that's great, but that does not prove anything. Why can we not use T and its perpendicularism to n and S right now? Well, keep in mind here, you may be saying, well, Mr. McGuckin, we've already been talking about, you know, how when two lines are cut by a transversal, if the corresponding angles are congruent, you know, da-da-da-da-da. That's great. But remember, we cannot claim that the corresponding angles are congruent unless the lines are parallel. And as of right now, we do not know that these two lines are in fact parallel. So we can't jump to the conclusion that this right angle down here and angle 2 are congruent corresponding angles yet. But what we can say is that yes, by the, actually let's back up. Hold on, let's back up. Yes, since angle 1 is congruent to angle 2 and angle 1 and angle 2 form a linear pair, then n is perpendicular to S by the linear pair perpendicular theorem. So there's our linear pair perpendicular theorem and how we can utilize it in some context.